Hi, I'm Chris Hadfield, living and working here aboard the International Space Station. Our sun is constantly pouring and churning out a stream of electrons and protons. This is sometimes known as a solar wind, and occasionally activities on the sun can cause big, powerful gusts in the solar wind. And when a sudden blast of solar wind heads towards the Earth, the impact often triggers the more intense displays of the northern and the southern lights. Solar storms can also cause problems with radio communications and GPS signals. In orbit, solar storms can be harmful to satellites and can cause havoc with our equipment and our bodies here on the space station. They can endanger us humans with potentially lethal doses of radiation. If such a threat were to head towards us, we could take shelters here on the station where we have thicker radiation protection. But to help predict radiation risks, we're currently running a Canadian-made experiment on board called Radi N2. Radi N2 will help create a map of radiation throughout every habitable area of our home here in space. Long-term exposure to radiation can damage us and potentially cause cataract or bone marrow damage or even cancer. Radi N uses bubble detectors. These instruments are placed around various ISS modules, and each detector is filled with a clear polymer gel, inside which are liquid droplets. And when a neutron strikes the test tube, a droplet may be vaporized. This creates a visible gas bubble in the polymer. Each bubble, which represents neutron radiation, is then placed within an automatic reader and counted. And the CSA's support of this radiation research may not only lead to major advances for future human exploration of space, but also in our knowledge of the health risks of radiation itself. To learn more about the Radi N project, or to see northern lights each night, check out the Aurora Max page on the Canadian Space Agency website.